Today we're going to be working on Unit 2, Lesson 6 notes. This one is growth and decay using log and natural log. So two things you do want to write first is growth and decay formulas. You will be using these later. So hopefully you remember the growth from our last lesson. Decay, you'll be using it on your assignment, but I just want to make sure you have it. It's almost the same formula. It's just going to be a negative RT. Okay, so here we're going to do, you're an epidemiologist, a person who studies the outbreak and spread of diseases. Part of your job is to help avoid a pandemic, a worldwide outbreak of a disease. You know that some of the most difficult diseases to deal with are viruses because they don't respond to many of the medicines we have available. And because viruses are able to mutate and change quickly, making it more difficult to contain them. You have been studying a new virus that causes people to break out in spots. Suddenly, a colleague rushes to your office to inform you that there is a confirmed outbreak of the virus in Europe. So, the growth of this virus through a population is continuous. Now, that big hint word tells us that we are using the E formula, okay, at a rate of 3% per day. So this is your rate. And remember, we're dividing the 3 over 100, or just move your decimal 2 places to the left. And we have 5 confirmed victims. So that is our initial amount, okay? So it says how many people will be infected with the virus on day 30. We're going to put it into our formula. A equals 5 because we know we have 5 confirmed victims. E to the R, which is 0.03. And we want to know on day 30 how many there are. And you would put this straight into your calculator or go on to Desmos, either one, and you're going to get an answer of 12. Okay. We're going to create a model of this one. To simplify it, we consider 5 victims as our day 0. So our first one we're going to do is our table. So we're going to get X and Y. X is going to be this one's going to be our days. And these are going to be the number of victims. And we can I went through already, and I just picked numbers that work really, really well. 0, 10. Well, we're going to count by tens because it's going to make it a little easier. And if you remember, we already know on day 30, we are going to have 12. Okay, and at day 0, we do have 5. I'm going to show you how to put that in Desmos in just a second. And we're going to start labeling our table. So these are going to be days. And I'm just going to count by 10. And here I'm going to count by 2s. Just going to make it easier. And these are going to be the number of victims. Okay. So let's go ahead and try to put this into Desmos. And we're just going to go straight to the graphing calculator. And we're going to go put in our formula. But let's see if A works on this one. Sometimes it works, sometimes it doesn't. E, I'm going to raise it to the 0.03. And I'm just going to go T. Let's see. And so if you come up to the gear sign and you go to the table, It's not going to let us. So let's go ahead and just change this to be y. Get rid of that. And change this t to be x. It's going to, whoops, x. And then it makes it a lot easier when you do graph. And I'm just going to go ahead to another line. 20, 30, 50. And as you can see, when we did 30, we got 12.29, but you cannot have a partial victim. So we're just leaving it. So we do have our numbers. So we have 6, 9, 12, 16, 22. And we come back to here. And we're going to plug in our numbers. So 6, 9, 12, 16, and 22. And then we're going to go ahead and graph it. I'm going to change the color so it makes it a little bit brighter. Let's do. So at 0, we're going to be at 5. About right here. 10, we're going to be at 6. 20 is at 9. You can see it is increasing. 12, 40, 16, 50, we're going to be at. And you can see we are increasing. Whoops. Can't exactly get it straight today. Very similar to an exponential. And if we continued on, we could see that. All right. Okay. So when will there, says when does your model predict there will be 50 victims? And show your answers. So what we're going to be doing, oops. Okay, you could look at your graph. We could look at it, but we're also going to check to make sure we get about the same. We could check to see. Well, our graph is a little too small, but you could look at it on Desmos. So we want to see when they're going to have 50. And then we write our original equation. Okay. The first thing we want to do is we want to get rid of the 5. We want to get e by itself. Now, in order to get rid of e, we are going to multiply both sides by the natural log. And if you look at your calculator, the natural log and e should be almost the exact same button. One of them should be a shifted. This means that they eliminate each other. Okay. And we get ln of 10 equals 0.03 t. I want to get t by itself. 3. And you're going to put this straight into the calculator. And we get about 76.75. So in 50 days, we'll have about 76 patients. In 76 days, we'll have 50 patients. All right. So these are just some practices. We want to see if we can practice getting rid of the e. We're going to do the natural log, which is n. So again, we're going to practice this. We're going to go -8 because they're being multiplied. I did that right. Okay, so we get this to be a decimal, and sometimes your answers are going to be decimals. It's fine. And we're going to multiply both sides by natural log. That gets rid of all of that. And it just brings it down to be -t equals natural log of 6.125. And we want to get t by itself, so we're going to divide it by everything by -1 because we want the t to be positive. And if you put this in your calculator, whoops, put this in your calculator, you should have negative 1.81. Okay, so let's look at the next one. Again, we're going to divide by 2. And we're going to get e to the 8x equals 22.5. Going to multiply both sides by the natural log. We'll get rid of this. And we get 8x equals the natural log, 22.5. Divide both sides by 8. And when you plug it into the calculator, oops, that decimal doesn't look great. 8, 9. All right. The next ones are exactly the same concept, except that instead of being multiplied, they're being added and subtracted. So we're going to, whoops. So we're going to do the same thing. Sorry, as soon as I touch the board, it likes to move. So we're going to minus the 8 on both sides. We get 27. We're going to do the natural log on both sides. That will get rid of this. And we get negative 4x, the natural log of 27. And we divide both sides by negative 4 to get x. And when we put it in our calculator, and don't forget to put in the parentheses, so you actually get the right number. Okay. Same concept for the next one. Whoa. It likes to move. Minus the 4 on both sides. We get e to the 3r equals 55. We're going to do natural log, and that will get rid of that. And so we get 3r equals natural log 55, and we want r by itself, so we're going to divide both sides by 3. And we're going to get 1.34, and usually I like to round it. So I like to do 2 numbers after the decimal, and then you're going to look at the third one to see if you're going to round it. All right, now you're going to be ready to do your assignment. Good luck.